this video is for the domain and range of exponential functions foldable. So the front side of it is split into graphs and equations. So we're going to look at graphs first. How do we find the domain and range from the graph of an exponential function? All right, so remember, domain are your x values or your input. Range is your y values or your output, your f of x, that little piece. So when we have a graph and we've got arrows, and I know it's hard to see, but at both ends of this exponential function, we have arrows, okay? So that means it's going to go on and on forever to positive infinity, and then this way it's going to go on and on forever to negative infinity. So my domain here would be all real numbers. And so this is that exponential function we saw in the last video that was decreasing, okay? So remember with these, y is never going to get below 0, okay? So your range, y, is always going to be greater than 0. Not greater than or equal to. It will always be greater than 0, okay? So on a graph of an exponential function where we have endpoints here, okay? We're just going to find the domain of this one. So when we have endpoints, we look at the two x values. So this x value, and I know it's hard to see on there, this is a -4, and this one is a +4. This is counting by twos. 2, 4, and I'll just go ahead and draw them in there for you. 2, 4, 6, 8. So this one would be -2, -4, -6, -8. So the domain, again, is our x values. So our smallest x value right here is a -4. And we've got an open circle. So remember, with an open circle, we use the less than sign. X goes in the middle. And then our other endpoint here is a solid circle. So that's less than or equal to. And that x is at a +4. So our domain would be -4 is less than x, which is less than or equal to 4. So again, it's just wanting the domain. It's just wanting the x values. Okay? All right, so with equations, it says find the domain and range of the following function. F of x equals 3 of x. So we're going to actually create a table. We're going to graph this function, and then we're going to find the domain and range. So we're going to go to y equals, and we're going to type 3 to the x power. So I'm going to type a 3. I'm going to use my exponent key right here above division, and then type the x in. And so I can graph it so I can kind of see what it looks like. Okay, so this is an increasing one because our b value here, the number that we're raising to the power, is greater than 1. To do the table, we're going to do second graph, and that'll bring up my table for me. And I'm going to go up here to where x is -2. Okay, so where x is -2, I've got 0.111 repeating. I want that in a fraction form. So what I'm going to do, I'm going to type it in 0. And I'm going to type 1s until this little arrow pops up. So you see the little arrow that popped up here? Now I can do alpha y4, and it will change it to a fraction for me. Okay? So back to the table. Where x is -1, we've got 0.3 repeating. Well, I know that 0.3 repeating is a third. So it is really handy to learn some of the more common decimal conversions to fractions, and just kind of makes your life easier. So where x is 0, y is 1. Where x is 1, y is 3. And where x is 2, y is 9. So now I'm going to graph this. I'm going to graph the easy points here. So just the x is 0, 1, and 2. So when x is 0, y is 1. When x is 1, y is 3. And when x is 2, y is 9. And so I know what this is going to look like. So if you need to put more points in, you can always kind of guesstimate. -1 is a third, so it's going to be about there. -2 is a ninth. That's real small. But I know what these exponential functions look like. That's why we kind of learn the rules and visually what they look like, so we can kind of fill in the blanks when we get those harder to graph numbers. But this function is going to just skirt that x-axis. It's never going to cross it. Okay? So my domain and range now. My domain is going to be all real numbers. I can plug any x into that equation that I want. Let me drop that calculator real quick. Now my range, y, is always going to be greater than 0. So when you have the 2 arrow endpoints, your domain is all real numbers, and your range is always y is greater than 0. Y will never dip, or your graph will never dip below that x-axis into the negative y's. All right, so we've got find the range of the following function given the domain. So they've given us the domain. They've given us the x's, okay? So we've got 2 of x. So I'm going to go back to my calculator, and in y equals, I'm just going to swap out that 3 for a 2. So that's my function, 2 of x. So second table, so when x is 0, y is 1. When x is 1, y is 2. When x is 2, y is 4. And when x is 3, y is 8. So there's 2 ways that we can write this range. If we're talking about the graph, okay, and I'm talking about the graph where x is 0 to where x is 3. Okay, so we're talking about the equation. We're not talking about a specific set of ordered pairs. So remember, if it's just ordered pairs and they're not connected, then we would just write 1, 2, 4, and 8. But since we've been given the equation and we've been given this parameter here, as long as x is greater than or equal to 0 and as long as x is less than 3, I can write my range using those values. So 1 is less than or equal to y, which is less than 8. Okay? So again, if we're just given ordered pairs and we're not given the equation in this parameter here, then that's when we would write the individual numbers. So the following one says, find the range of the following function given the domain. So we've got 0.5 to the x, and then here's my domain. So here is that example. We are just given for these x values, none of the x's in between. So we're going to go to y equals and do 0.5 to the x power, second graph. All right, so where x is negative 5, y is 32. Where x is negative 4, y is 16. Where x is negative 3, y is 8. Where x is negative 2, y is 4. Where x is negative 1, y is 2. Where x is 0, y is 1. And where x is 1, so we got 0.5, which is a half. So again, here we're given this parameter, all the x's that fall between 0 and 3. So that's why we can write the range this way. On this one, we are given just these specific values. So negative 5.5, we don't want to include that in our domain and range. So for the range here, we would just write our y values. I'm going to write them in numerical order. So 1/2, 1, 2, 4, 8, 16, and 32, and write them using those brackets. So it's very important to understand the different parameters and how you need to write the corresponding domains or ranges when you see those parameters.